Okay, so we've been talking about shapes and how to find their areas. So we don't really seem to have a huge problem figuring out. No, that's not right. Figuring out shapes that are parallelograms, right? So here we have a rectangle, pretty straightforward, right? As long as we have the base and the height, right, we're pretty good, right? And it makes sense because there's a fixed ratio, right? All we're trying to do is find the area. So we're going to have a certain amount of cubic units right here on the ground floor, right? So the base is so long, and if we have a cubic unit, like say it's a cubic centimeter, right? There's only going to be so many centimeters that are going to be on that first row. The higher you go, right, if it's 1, 2, 3, 1, 2, 3, 4, right? So we have 1, 2, 3, 4, 5 in centimeters of height, then you're just going to add that many more rows of cubic measurement. Right? So it comes down to a very simple equation of base times height is equal to area. Great. We've also had success, right, with just parallelograms. Because what ends up happening is if you take a parallelogram, all it really is taking one of these shapes, these regular shapes like rectangles, and it's like you're knocking it on its side, like you're punching it or something. Boom! Crunch! And it goes over. The actual space inside is the same, right, as if it was a regular, like a rectangle, right? All that's happened is that it's moved over, right? And the area stays the same because the distance between this side, this side, this side, and this side are all the same. That's what a parallelogram means. Right? So the spaces are the same even though we've knocked it over on the side. So we're fine using area and base and height. Right? Base times height equals area. And we're going to use base times height. Right? And we're going to use that language, base times height over length times width, because base and height apply to triangles, they apply to parallelograms, and they apply to rectangles and squares. So, base height, great. Works for both regular rectangles and squares, and it works, oops, stop that, and it works for our friends the parallelograms, right? And a variation of it will even work with triangles. Right? All we have to do is then take area equals base times height and then divide it by 2 because all triangles are basically half of an imaginary parallelogram. Right? Okay. Now, today's challenge is going to be this. What are we going to do with a shape that's not a triangle, not a rectangle, not a parallelogram? It's a trapezoid, meaning it's got two parallel shapes, two parallel sides, and then two sides which are definitely not parallel. Right? So it doesn't apply to the same rules. The base times height does not work because this side could be very, very different than this side, just depending on what angle this is. So we need to come up with a new strategy that's going to apply to any trapezoid that we can think of. Right? And a trapezoid, again, is just what happens when we have two parallel. Pretend that these are parallel, I know. Yeah, they're not. Hold on, let me see if I can fix it. Okay. Let's try again from the beginning. Any parallel, any trapezoid, right? And of course a trapezoid is just any two lines that are parallel connected by to any two other lines which are not parallel, right? This line isn't parallel to this line, right? So it's basically half parallelogram. How are we going to solve that? There is a formula, there is a recipe we can come up with that will work for this. What is it? I'm going to give you time with your geoboards to work that out. Okay, and then we will all take notes on the solution we come up with. Okay, so we'll distribute the geoboards and then get started.